Welcome to homeschooling. I hope you guys are doing well. Now today we'll be looking at what we call the equation of a straight line. Now here we have GeoGebra software, and I'm simply just going to input a straight line, and we're going to look at it and see what we observe. So let us say we go y equal 2x plus 2. Now I want you to notice something here. Look at the equation of a straight line, y equal 2x plus 2. Let me input our next equation, y equal 3x plus 4. There is something unique about the general equation of a line and the line itself and the Cartesian plane. Now look at the first line, y equal 2x plus 2, which is this line right here. And look at the equation of the second line, which is this one right here. Now you must observe that there's a connection between the straight line, because if you notice, this 2 right here in the equation on the left represents where the line actually cuts the y-axis here. And where you had the 3x plus 4, it also represents where the line cut the y-axis, which is at 4 here. We call that the y-intercept. Now let us input a different line where we probably had y equal negative 5x minus 3. Now notice that this line also cuts the y-axis at minus 3. But notice the first two lines are slanted upwards from left to right. This line is slanted downwards, and it was not slanted downwards until we actually introduced this negative 5 here in front of the x. So that is actually helping me to tell me a lot of things. Look at the steepness of the lines as well. You would have noticed that the negative 5x line has the steepest slope, as you can see coming down here. The one with y equal 3x plus 4, that steepness is less, well, it's less steep than the negative 5x line, and the line before has the smallest amount of steepness. And of course, that must be accounted for by what you have right here. But we're going to show you how all of this is now connected in terms of the equation of a straight line. Once again, I've now introduced a new line, which is y equal 4x plus 2. Notice that this line cuts the y-axis at 2. So we're saying this value here always seems to be the value where it cuts the y-axis. In other words, the y-intercept is always going to be a part of the equation. Now what I want to find out is, how do I get this 4 value here? Now let us look at the gradient of this line. Now to find the gradient of a line, we just simply need to choose 2 random points on the line. So let me choose that point there, and let me choose this point up here. Alright, what I'm going to be looking at here is the run and the rise. Now, at point A right here, the run here is simply just 1, because you can actually see that we go across 1. And to get to this point up here at B, the rise would be 1, 2, 3, 4. Bear in mind that gradient is rise over run. So we are saying that the gradient of this line is the rise, which is, let me go again, 1, 2, 3, 4, over the run, which is 1. That gives me 4. So automatically I can now say that 4 right here in the equation, 4x plus 2, must represent the gradient of this line. And that is actually how we get the equation of a line. It constitutes of 2 main factors: the gradient of a line and the y-intercept. In other words, where the graph cuts the y-axis. For GeoGebra software, we all agree that the equation of a line takes on the form y equal mx plus c, where m is the gradient or the steepness of a line and c is the y-intercept. Same thing as saying where the line cuts the y-axis. Now we have ourselves here a straight line, right? We don't have to look at the entire line. We can look at a specific section of the line. So let us look at this section right here. This section right here. Now we said that the equation of a line is y equal mx plus c. We can clearly see what the c value is, because this line cuts the y-axis at 3. So we can say that c is equal to 3. Now what I want to find is what my gradient m is. So looking at that section, and notice what the line is doing here. Instead of slanting upwards from left to right, it's slanting down. So we know that whenever we move downwards, that's negative. So let us look at this right here and count going down. So I'm going down from, this is 1, this is 2, this is 3 going down. Alright, so this basically my rise would be negative because I'm going down. So my gradient m would be equal to negative 3. I'm moving forward. So my run is positive, and I would have moved 1, 2 places forward. So my gradient, well, my run would be 2. So I have negative 3 over 2. Now I have all the components that are necessary to make the equation of a line. So let me just go over to the left here. So the equation of my line here, my gradient, which is m, is minus 3 over 2, and my y-intercept, which is c, is equal to 3. So my equation is simply going to be y equal minus 3 over 2 x plus 3. Guys, here's typically what a question could look like. Determine the equation of a line that passes through the points a 1, 4 and b negative 2, 6. I want that equation. I'm going to start by writing the general equation of a straight line. So by now, we know that the general equation of a straight line is y equal mx plus c. Of course, you know that m is the gradient and c is the y-intercept, right? So let me just take those 2 points up there, a and b, and write them back down here. So we have a, which is 1, 4, and b negative 2, 6. So a is 1, 4, and b is negative 2, 6. All right. Let us call this x1, y1, and x2, y2. Let us start by finding the gradient because you guys would have found the gradient already. You know, we use the formula m equal y2 minus y1 over x2 minus x1. And of course, when you say y2 minus y1, you're really saying what the rise is, and x2 minus x1 is what the run is. All right, so breaking this down, I'm gonna have gradient, which is m, is equal to 6 minus 4 all over negative 2 minus 1. All right, taking this down, I'm gonna have the gradient m is equal to 2 over minus 3. And of course, I could just write this as m equal negative 2/3. So that basically is my gradient. So let me write the equation now. Y is equal to minus 2/3 x plus c. Now clearly you see what my problem is. I need to know what the c value is. But that is not a problem because we have two set of coordinates for x and y. I can choose to use whichever one I want, a or b, to find that c value. I'm going to use a. So I'm going to say using a, which we know to be 1, 4. What does this mean? It means that when x is 1, y is 4. So I'm going to have 4 equal negative 2/3 x is 1 plus c. Good. Now when I multiply negative 2/3 by 1, I'm going to end up with 4 equal negative 2/3 plus c. Now to get rid of this negative 2/3, you know that we add 2/3 to both sides. But I'm just going to show it on the left hand side. So I'm going to have 4 plus 2/3 is equal to c. So therefore c would be equal to 14 over 3. Now that I have my c value and I have my gradient, which is negative 2/3, I am complete. So I can say therefore the equation is y equal negative 2/3 x plus 14 over 3. And you know what the purpose of this equation is? It is to generate any coordinate on the line. In other words, if I have a specific x value for a point, I can find the corresponding y value for that point. And if I have the y value, I can find the corresponding x value for that line using this equation. Ask me, why is it that I'm learning linear equation, or how is this important to real life? I should tell you that linear equations has a lot of real life applications. Namely, one of them for persons who do physics. You use it in kinematics with equations of linear motion that refers to a straight line as well. But let us say it's now corona time. For example, I want to stock up on tin food. Alright? Now let us say you're stocking up on mackerel. But you probably check at home and you have, let's say, 24 tins of mackerels, hypothetically speaking. Let us say you decide that every day you are gonna buy 5 tins. So every day you're gonna buy 5 tins. So 5 tins per day. All right. Now we realize that that 5 that you have there is related to time because On day one, you decide that you're gonna buy 5 tins. So on day two, you buy 5 more tins. You're gonna have 10. So notice that 2 days would have gone, and for those 2 days each, you bought 5 tins. So that is 5 times 2. So it means that time will change. So we're gonna have to create an equation here. So let us say y is the amount of tin of mackerels you'll have. Bear in mind that initially you had 24 tins, so 24 is a constant. Every day you're gonna be buying 5, so you're gonna have 5, and let x be the number of days. Alright? So y represents the number of tins of mackerel. X would be the number of days right here. And every day you're gonna be buying 2. So what if I ask you how many tins of mackerel would you have after 4 days? Alright, since x is the amount of days there, all I would have to go is y equal 24 plus 5 times 4. Alright, which is y equal 24 plus 20, which is y is equal to 44 tins. So basically what I did here was to create a linear model that makes it easy for me to work out how many tins of mackerel I would have over a given period of time. And so powerful is linear equations that you yourself can actually create a linear model for basically a lot of things that happen. The rate at which you probably full of bought, alright, you will probably create a product and you want to decide how this product is selling. You can use an equation to model these various scenarios.